In this session, we're going to be taking a look at Kubernetes Event Drive Autoscaling, or KEDA, and in particular, we're going to be looking at its integration with Azure Kubernetes Service, otherwise known as AKS. We're going to see how KEDA enhances the scaling capabilities of Kubernetes, and in particular, why it's effective in the Azure cloud and how it can interact with other Azure resources. I think before we start delving into the demo portion of this, we should probably take a review of how scaling works in Kubernetes by default. So natively within Kubernetes, we can use the horizontal pod autoscaler, which will take our deployment consisting of a number of pods, and based on the resource utilization of those pods, horizontal pod autoscaler can scale our deployment. This is good for some workloads which have a reliance on resource usage, but for other workloads that maybe rely on external systems, we want to take a more application-centric approach to our scaling needs. And this is kind of where KEDA comes in. So KEDA, as the name suggests, allows us to scale our deployments based on events. And those events can be in many third-party systems. There's a number of scalers supported. You can see there are things in here such as Apache Kafka. There's some AWS resources, Azure resources, even databases, so Cassandra. There's Postgres in here as well, MongoDB. So there's a whole bunch of systems that we can use KEDA to integrate with and scale our deployment based off of metrics in these systems. I think the most basic example here, and the example I'll be using for the demo, is that of an Azure Storage account. So, not Azure Storage Queues, rather. So within a storage account, we can leverage the queue functionality, and based off of the number of messages in that queue, we can have KEDA scale our workload in the form of a deployment on Azure Kubernetes Service. To take a more architectural view of that quickly, we have our storage queue in an Azure Storage account, and we will imagine that there is some external application that is sending messages to this queue. And our workload will need to pick up those messages and perform some processing on those messages, and then delete the message once it's done with the processing. Our application workload is deployed to Azure Kubernetes Service, and it consists of a deployment where each instance or each pod in that deployment is able to process some number of messages each second. So let's say it can process one message every 3 seconds. Obviously, depending on how many messages are coming into the queue, our deployment will need to scale based off of that. And if you imagine back to native Azure Kubernetes Service, or native Kubernetes indeed, this might be quite tricky. We would need to look at the resource usage of those pods, and we would only be able to use the horizontal pod autoscaler to scale based off of the resource usage. And depending on how we're processing those messages, we might not actually be using a lot of resource in each of those pods. And so it presents a bit of an issue in terms of autoscaling. So with that in mind, the alternative there would be maybe to have some custom script that would check the storage queue and would scale our deployment based on the number of messages and scale down again in the future. And that is a reasonable approach, if not slightly hacky. KEDA addresses that in a more productionized way, and we can see the resources that KEDA leverages on the left. So in addition to our workload resources, such as our deployment, our service account, and our pods, we have some KEDA specific resources. And the main one really is a scaled object. And a scaled object defines the scaling behavior, both scale up and scale down, and it can be linked to, in this case, a deployment. And in that scaled object definition, we define the resource we're going to integrate with, in this case, an Azure Storage account. And we can control the triggers for that scaling. So we can say if there are more than 10 messages in the queue, we want to trigger some scaling. We can set the minimum number of pods in the deployment, the maximum number. And an interesting facet of KEDA is that it actually enables us to scale our deployment to 0 instances, which is not something you can do natively in Kubernetes. So that also can be quite powerful in terms of resource savings for deployments with sort of larger pods. KEDA uses a trigger authentication object, which effectively uses in the case of Azure, we can use an Azure workload identity to authenticate to our storage queue. And in fact, we're using that for our deployment too. So for workload identities, we can take a user assigned managed identity in Azure, and we can federate that to a service account within Azure Kubernetes Service. And in doing so, it means that the service account used by our pods and also similarly used by KEDA can use Azure RBAC authentication to Azure resources such as our storage queue here. So we can imagine that KEDA will use a user assigned managed identity with storage queue data reader role on the storage account, and we can have our workload identity with storage queue data contributor on the storage account. That all uses OAuth, which means that we don't need to store any passwords anywhere. We don't have to have a key vault linked up to this and store secrets in Kubernetes. It all just happens through OAuth. The lab I'm about to show is fully documented. So we have a public GitHub repo here with setup instructions for the lab. This lab includes a couple of applications. So there is a message processor application, which will process a message every 3 seconds by default, although that is configurable. And then there is a message generator application, which mocks the generation of messages into our storage account. I'm going to copy this. If we swap over now to our terminal, I'm using a tool called K9S here to monitor. We have here in the top right our deployment view, our Azure Queue processor. And in the bottom right, we have a pod view of the pods in that deployment, or really in our namespace. At the moment, our deployment just has a single replica. And in that, we can view the logs, and we can see in our single instance of our message processor, there are currently no messages to process, and every 20 seconds, we're reaching back out to that Azure Storage Queue to see if there's any messages to process. So by default, in this case, we have a single pod, and that's how we've configured the scaling for this scenario. So there's always something checking the queue to see if there's any processing needs. We could, in theory, scale this to 0 because KEDA would be doing the checking for us. But I think this is a nicer demonstration. So let's generate some load. Here I'm just going to paste in the definition for the message generator pod. This is all explained in the GitHub repository if you want to follow along or test this for yourself. And our message generator actually takes in a couple of environment variables. So we can set the maximum number of messages we want each minute, and we can set the minimum number of messages each minute, and it will generate a random number of messages every 60 seconds. The idea being that depending on how many messages are thrown into the queue, KEDA will need to scale our application appropriately. We might need 3 pods, we might need 300 pods to handle the requests. And the idea is that KEDA is intelligent enough to be able to handle that for us. So let's run this. Our storage generator is created. We'll go in there and we can see immediately we've sent 191 messages to the queue. If we open K9S on this screen, in fact, we can see in the top right already, we've scaled up to 5 instances for our queue processor. If we go into one of these, we can see some output. So our instance here is processing some of the messages we're getting through. For instance, we processed, batch 1, message 46, and then 56. We're now on 10 deployments, which makes sense. To effectively here, we're now processing every 10th message just for this instance, because the other 9 instances are processing the other messages. If we go back to the pods view, we can see this is running nicely. What we should see once the queue is finished is that these will scale down. Now, it can take a moment. So we've sent batch 2 of another 174 messages, but at the time that those messages were sent, obviously we were still scaled up. Now we can see we're scaling up to 18 instances to handle this load. What we should start to see is that we will get on top of the message queue essentially, and that by the time 60 seconds has elapsed, we will have cleared the queue, and we will see over time this will start to balance out. Go back to the pods view, we can see that better. What I will do now to simulate downscaling, which it has just done, is that it will actually stop the message generator pod. So there's now no more messages being sent to our queue. Obviously, there's still some messages in there to process, but it seems they've all been processed now. So now we're back to 1. And in fact, if we go into the logs for this, no messages to process. So sent some messages to the queue. KEDA scaled up our deployment. We process those messages almost in real time, and scaled back down again once the queue was processed. So that was a very quick demo for KEDA using Azure Storage Queues and Azure Kubernetes Service. I hope this has been useful. Do follow along with the GitHub repo if you want to test this for yourself. Thanks for watching.